Hi, this is Colleen. This is my project for Embedded Systems, Project 3, calculating rotations per minute for a servo motor. So I have the servo motor here. I've used construction paper as my propeller. It is plugged into the ESC, and then I use the quadcopter base, and it's not plugged in right now, but when I run it, you plug the 3-cell LiPo battery into that, and then the 3-cell LiPo battery powers the servo motor, and it has about a max of 11.1 voltage. And then here you can see that the ESC is also plugged in to my ground via one of the breadboards. I'll actually pull this one out. And then it's also plugged into pin 9. So here we have the IR detector. This had been underneath when I was running it. The IR emitter is here, and it was taped to the top here so that they were facing each other. And then this was spinning in between them. So the IR detector is receiving its voltage from here, the 5-volt pin, which is the red wire. It comes here, it goes through a 2K resistor into the negative leg of the IR detector, and then the other positive leg is grounded to the Arduino via the brown wire. And then this blue wire here is the output, and the output goes to, this is kind of like a configuration switch I created. So it tracks to here, and by moving this between these two columns, it can be digital or analog output. So the blue wire goes to pin 2, sorry, and then the green wire there goes to the analog A0 pin. And that was just so that I could test and go back and forth. And then for the IR emitter, you can see I have a 220 ohm resistor here. It is connected to pin 13 to power it. And then it goes through the 220 ohm resistor to the IR emitter. And then it is grounded with the yellow wire back to the Arduino. I think that covered everything. And then I have another video that will show it. But basically, once this starts running, the detector is on the bottom, the emitter is on the top, and this will go in between them. And then every time the blade constructs or obstructs the path between the two, it'll trigger an interrupt routine to increment the RPM count. And then the loop function calculates the RPM using that count. And so the majority of the work is happening in the loop instead of the interrupt routine. And the calculations came out about accurate. For a 3-cell LiPo battery, you would expect a max RPM to be 11,100 RPM. I set mine at about 28% of the max and ended up with an RPM, I would think about 3,078, which is maybe like 5 RPM lower than what it should have been. I think it's like 3,083. So it ended up being pretty accurate, so I was happy about that. Okay, that's it. Cool.